Hi. If you missed class or need a recap on what we did in class on this worksheet for Newton's first law, here we go. So Newton's first law is that lazy law where objects like to do what they were doing already. If they were at rest, they stay at rest, and if they were in motion, they keep going in the straight line at the same speed. In other words, they keep their velocity unchanged unless something else comes in. And the forces that act on the object in this case are all balanced out. And remember, we're going to talk about forces that are in the same direction, collinear. So if you have a perpendicular set of forces, you do not compare them to each other. You only look at vertical forces compared to vertical forces, horizontal forces compared to horizontal forces, and sometimes if a force is at an angle, you kind of have to split it into two directions and then deal with it accordingly. So the schematic expression for Newton's first law is right here. So if net force equals 0, then V is constant, and that V can be either 0 or it can be like 5 meters per second north or whatever you want. So it is remaining the same unless there is an unbalanced force. And in that case, so if there is an outside unbalanced force coming in, that will be Newton's second law, which is force equals mass times acceleration. But if net force equals 0, that's first law. It's equilibrium, meaning all forces are balanced out. And then in that case, V can be 0 or V, and it's with the direction, can be constant. So it's important to remember that the object won't turn or will not deviate from its course. And all examples here are for our objects in equilibrium, meaning they're either at rest or they're moving at a constant velocity. So in example 1, we have a box that is not moving. We have the mass for the box. So we're going to say mass is 5 kilograms, and there is a force to the right. So to draw a free body diagram, so we get ourselves a surface, we get ourselves an object right here, then force of gravity definitely downwards, and a matching force, normal force, that should be equal to mg, which is the formula for force of gravity. It's right here, you can see it. Force of gravity is found by multiplying mass times 9.8. And then we have the 15 Newton force to the right. So the thing is, if I just leave it at that, the box would be moving and moving with acceleration. The reason why the box is not moving is that there is a matching force of friction in the opposite direction, and that will be our force of friction static because the object is not moving. So here's our FBD. Now let's figure out the magnitudes. So magnitude for gravity will be the same as magnitude for normal, or rather normal will be equal to gravity, and gravity is found by multiplying mass times 9.8. So force of gravity equals normal force and equals 5 times 9.8. So it's going to be 49 newtons. And then force of friction, like we said, since it's force of friction static, it equals force of pull, and it equals 15 newtons. So that's the solution for example number 1. Example number 2, we have a skydiver who is moving at a terminal speed of 160 kilometers an hour. That is a number, but you're not going to be using that number at all because the only thing that matters to us is the terminal speed. Terminal speed means that V is constant, which tells us that all the forces on this skydiver are balanced. There is no surface for it. Therefore, we're just going to draw it like this. No horizontal surface, force of gravity. And because we know this person is moving at a terminal speed, that means the forces are balanced. So force of air, or force of air drag, force of air resistance, and force of gravity are equal and opposite. So force of air equals 686 newtons, and therefore force of gravity is also 686 newtons because V equals constant. Here, the reason for all of these was V equals 0 or rest. Here, V is constant, so therefore the forces are balanced. And then, what is the mass of the skydiver? The question is, mass will be 686, which is the value for force of gravity divided by 9.8. And whatever that is will be measured in kilograms. Example 3, a 45 kilogram container is pushed at, again, constant velocity across a rough carpeted floor. So that gives us an idea that there will be force of friction present, and we have force of gravity, obviously, always. Normal force, because it's flat on the ground, these guys are equal. Then we have 264 newtons of pull. And I know that because they gave me force of friction, and it's going to be kinetic because it's moving. So force of friction, they gave me to be 264 newtons. And it will be equal to force of pull because velocity is constant. So I don't really need to calculate anything. I know that they will be equal, balanced because of the constant speed. And then force of gravity is going to be equal to normal force. Again, rest vertically, it's not even moving, and it will be 45 times 9.8 mg, and it's going to be measured in newtons like any other force. Example 4, this is for our honors students, or it could be a bonus for regular students. So in this case, we have, and this is Hill, not his, we have an incline, and a box is resting on the incline. So when you have a problem with an incline in it, the first thing you're going to notice is that force of gravity is going straight down like that, and it acts in two directions at the same time. So first off, your x and y directions are such, x and y. So you have mg, or force of gravity, going down straight. And then because the box is resting, I know that forces are balanced on it. And you're looking in the y direction and x direction. So this is mgy, and this is mgx. Now notice that I'm not drawing them separately because they do not exist separately. The force that does exist is force of gravity, and I already drew it. It's straight down force of gravity. Now, if this right here is 30 degrees, then this angle here is also 30 degrees. If you need me to explain it, let me know, and I will later in a different video. But for now, so because we have force of gravity acting in two directions, we need two extra forces to balance those manifestations of gravity in x and y direction. So in the x direction, I know that the object is trying to slide that way. Something is stopping it from sliding. Well, force of friction. And that force of friction, it will be static, and it will be equal to mgx, which is found as mg sine of 30 degrees, because remember that's a cross right there. So that's mg sine of 30. Normal force will be accounting for the vertical part of gravity. Now notice, again, remember I said normal because, not because it's not abnormal or crazy, it's because it is at 90 degrees to the surface. And this is our surface right here. This is a surface this is a force provided by the surface. So it's called normal because it is perpendicular to the surface that is providing it. And that normal force right here, it's going to be equal and opposite to this part of gravity. Whereas force of friction is equal and opposite to this part of gravity. And again, notice that these the components of gravity, mgx and mgy, are dotted because they are not real forces. They're just components of gravity. Now, if I were to calculate them, so mg is going to be 25 times 9.8 newtons, then mgx, which will be then equal to force of friction static, will be 25 9.8 sine of 30, which is half. So basically 25 times 4.9 newtons. And then force normal would be equal to mgy, and that will be found as 25 9.8 cosine of 30 degrees. So 245, I believe, roots of 3 divided by 2. And that is it for that part. Example 5, similar, only here we have a child is sliding, and my oversight, I didn't say it a constant velocity, but since this is a worksheet for just Newton's first law, go ahead and assume, even though assuming is not very good, but nevertheless, you have my full permission to assume that this sliding speed is constant downhill. And there we go again. This right here is 15 degrees, which I drew over 15, but mg, or force of gravity, mgx dotted, mgy dotted, normal force to counteract mgy, and force of friction equal to mgx, and in this case it's kinetic because our person, our child in the slide, is sliding down. So to find gravity itself, the real gravity, mg, 42 times 9.8 newtons. Then force of friction kinetic is going to be equal to mgx, which is equal to 42 9.8 sine of 15 degrees. And then force normal equals to mgy equals to 42 9.8 cosine of 15 newtons. There we go. That's it for this worksheet.